So example 8 tells us to find an angle theta in radians and a real number a such that sine of x minus the square root of 3 of cosine of x will equal a times sine of x plus theta. So if you look at your format right here, that's the format that the rejection formula is in. So this we could write as it's the a sine of x plus b cosine of x. Where what is a? What number is a? 1. And what number is b? Almost. The negative square root of 3. Alright, so what we can do then is we can take that a and that b, and that's going to make a point that would be on the terminal side of this angle. So this here gives me an ordered pair of 1 and the negative square root of 3. Okay, so if we look back at our rejection formula, first it says, if you read it, it says if AB is a point on the terminal side of an angle theta in radians in standard position, then for any real number x, a plus sine x plus b cosine of x is equal to the square root of a squared plus b squared sine of x plus theta, okay? And so it tells us that if AB is a point on the terminal side, and if you look at the picture there where they drew it, you'll, oops, don't know why that went that way. That terminal side right here, they put that point AB on it, okay? So we can see in the, I wrote the formula wrong. It's a times sine of x. I don't know why I put a plus. All right. So we see the a and the b here. So that's the AB. That's the point on the terminal side. Does that help a little bit?
Yeah.
All right. So, but also, I want to just go ahead and look at it because compare what we're looking for with what it's equal to. What do you notice? It told us to find an angle theta in radians and a real number a. What do you notice about a? Yeah, it's the same as that square root piece right there, isn't it? So we know that a is equal to the square root of a squared plus b squared. So can I find a now? Yeah, because we know a and b, don't we? Well, remember, a negative squared is a positive, right? And a square root and a square cancel each other, so it just becomes 3. All right, so there's a. Now, how am I going to find theta? No, I don't know sine of x. But I know an ordered pair, don't I? We said it was our a and our b, but what's an ordered pair also got in it? What other variables? X and a y. And so how can I find theta if I know an x and a y value? Well, I don't know what r is. I could find r, couldn't I?
Yeah, what is that?
But which one could I use that's just x and y? I don't have to find r. Tangent. So we could say tangent of theta is equal to the y over x, isn't it? So tangent of theta equals the negative square root of 3 over 1. Or tangent of theta equals negative square root of 3. But we need theta, don't we? So how can we find theta? How can I bring theta to be what it's equal to?
The reciprocal.
Not the reciprocal, but the inverse. I think that's what you might have meant, hopefully. So if we're going to take the inverse, so we have the inverse tangent. Well, it's a random point right there. So the inverse tangent of the negative square root of 3 will equal theta. And wait, we have ordered pairs on our unit circle that have the square root of 3 in it, don't we? We do. It has the square root of 3 over 2. But it's got a square root of 3 in it. Now, inverse tangent, what quadrants are we going to look at? First and fourth. Okay. Inverse sine and inverse tangent are both first and fourth. Inverse cosine is first and second.
Wait, tangent? I thought it was the third quadrant.
No. That's where you're thinking where it's positive. We're talking about the inverse, what quadrants we're allowed to look in, okay? So I can only look in quadrants 1 and quadrant 4. And since tangent here is negative, what quadrant are we going to look at? We're going to look in quadrant 4. So in quadrant 4, we have those two options there that have the square root of 3 in them, don't we? We have one that has an ordered pair, square root of 3 over 2, negative 1/2. And we have 1/2 and then negative square root of 3 over 2. Which one of those are we going to choose?
That one?
Why?
Because the y is negative.
No, the other one, the y is negative also.
But the
I mean, the square root of 3 is negative.
Okay, because it has a square root of 3 in it. You're right. I would pick this one. I shouldn't do that. Circle it. I would pick this one because remember, tangent is y over x. And so we want that square root of 3 to be on top. Okay? So that way when we do our keep it, change it, flip it, or we multiply by the little denominators, we still have a negative square root of 3 on top. So which angle has that ordered pair?
pi.
5 pi over 3, but that's the right location. But remember, tangent is, even though we say it's quadrants 1 and 4, it's between negative pi over 2 and positive pi over 2. So subtract 2 pi, and you should get negative pi over 3. And so there's our theta. So theta is equal to negative pi over 3. Now, it didn't ask us for it, but could we write what it's equal to? Could we write that then as an equation? Oh, that's the easy part. It'd be equal to A, which you said is 2 sine of theta. I'm sorry, x, not theta. Sine of x plus theta, so minus pi over 3. It didn't ask us for it, but if it did, that's what it would be equal to.